Good morning, everyone. Our lesson today is to solve a question 5 from 2Haikal for grade 12 advance. The question here: find the local extrema of a given function using the first derivative test. Question: I selected two questions here, question 15 and the question 19. First, question 15, as you see, y equals in first tan x squared. How to find critical numbers, then how to determine where is the function is increasing and decreasing, and determine the kind of the local extrema, local maximum or local minimum. Step 1, as you see here, the domain here for this function, domain equals from negative infinity to positive infinity. Step 1 here, to find the derivative, first derivative, if I promote the derivative. Here, as you see, we have roll here. This is the angle, maybe here. What the derivative x squared, 2x, then 1 plus angle squared. Okay, it's the angle here, x squared, also squared. This is equals, I think, 2x over 1 plus x to power 4. If look denominator here, as you see, we cannot denominator equals 0. Just the numerator equals 0, because this is the denominator always positive and always more than 0. Okay, this is 2x equals 0. That's mean x equals 0. This is a critical number. This is a critical number. Okay. Now, to study the sign of the first derivative, recognize the table as you see, x from negative infinity to positive infinity, then here put it 0. Okay, as you see, this is y prime equals 0 at 0. Okay, now to check the sign here, you can check point here between negative infinity to 0, negative 2, and from 0 to positive infinity, between them you can check any point, random, a random point, maybe 3. Or use calculator to check the sign. You can use this calculator, as you see. This is write the equation of the first derivative. What the equation here? This is a fraction. Sorry, this is a fraction. 2x over, keep silence there, 1 plus x to power 4. Then calc negative 2. What the answer is, positive or negative? Negative. Here the sign is negative, is here decreasing. And yes, also to check the another point, calc 3, the answer is positive. This is yes, increasing in this interval. We can here determine this is yes, this is here local minimum, yes, as you see. Maybe the answer is decreasing interval, okay, from negative infinity to 0, okay, increasing, okay, from 0 to positive infinity. Be careful, all increasing and decreasing intervals should be opened from the both sides. Be careful about this. Maybe that comes as a multiple choice questions, maybe like this. The question maybe comes like this: A, B, C, D here, the decreasing or increasing interval. For example, increasing interval maybe from 0 to positive infinity, from 0 infinity like this, or from 0 to positive infinity, or maybe from 1 to positive infinity. Which one is right? C for this increasing interval. Yes, be careful. You should open from both sides. Okay, this is very important point for you. Also here, what the coordinates for the local minimum. Local minimum, yes, at x equals 0, but what about the y? Y equals, you should substitute in the original function. In first tan, okay, x squared, then calc 0, the answer is also 0. We can say here 0, 0 is a local minimum, right? Okay, that's it. I think the question here, determine local extrema of a given function using that first derivative. That's it. Okay, let's move the next question. Question 19. Y equals radical or square root x to power 3 plus 3x squared. Here, as you see in this equation, what is the domain? The domain here, the condition here to make the square root is defined. What is the under square root? X to power 3 plus 3x squared should be more than or equal 0. This is the condition. Maybe here, to solve this inequality, make this inequality equals 0 first. X to power 3 plus 3x squared equals 0. Then study the sign. We can take here x squared as a common factor, or maybe you can use calculator. This is x plus 3 equals 0. Here, as you see, we have two choices. The first one, x equals 0 or x equals -3. But how to know which interval for the domain here? I need this equation or this inequality more than or equals 0. As you see, this is here, this is the number line from maybe, this is the number line, yes, as you see, from negative infinity to positive infinity here, we have 0, we have -3. To check the sign between them and we have 3 intervals from negative infinity to check where is the inequality is positive, as you see here. We can write the equation in your calculator here. Yes, this is radical x to power 3 plus 3x squared. Sorry, without. Yes, without. X to power 3. Keep silence, please. Keep silence. Plus 3x squared. Then we can select here -1. Sorry, here, excellent. Here, sorry for this mistake. Maybe here, yes, change. This is -3 before. Yes, -3. Then here what? Here 0. Yes. This is -4. Okay. This is -2. Keep silence. Here, this is 1. Okay. Calc. Now, calc -4. This is negative. Here in this interval, negative. Yes. Calc also here -2. The answer is positive. Good. This is also here calc 1. The answer also positive. This is in this interval we can write the domain here from -3 to positive infinity. Okay, this is the domain. This is the domain from here to there, yes. Now we can find the first derivative. Y prime equals, what the derivative under the square root? 3x squared plus 6x over 2 radical. Yes, x to power 3 plus 3x squared. make the first derivative equals 0. We can, yes. As you see here, we have 3x squared plus 6x equals 0. We can take 3x as a common factor. This is equals x plus 2 equals 0. We have two choices here, x equals 0 or x equals negative 2. And also x make the denominator equals 0, that's make the first derivative undefined. This is two critical number, 0 and negative 2. But negative 2 inside, yes, 0 and negative 2 inside the domain. Okay, that's good. Okay, now we can recognize a table to study the sign of the first derivative to determine where is the function is increasing, where is the function is decreasing. Okay, x here from negative 3 to positive infinity. This is the domain, negative 3 to positive infinity. This is y prime. Y prime, this is here we have negative 2 and 0. This is also 0 and here undefined. Yes, I think at 0 and defined. Okay, maybe you can use calculator to check this. Now we can select here, this is negative 2.5. Select a checkpoint here, negative 1, here maybe 2 or 3 or any point. Write in your calculator, this is the equation of the first derivative, 3x squared plus 6x over 2 radical x to power 3 plus 3x squared. Then calc negative 2.5. The answer is positive. Good. That means is increasing in this interval from negative 3 to negative 2. And also checkpoint for the next calc, next point negative 1 to get the answer. Also here this is negative, that's mean decreasing, that's mean this is local maximum in this point. Also calc to the answer is positive, this is go increasing, go up. Yes, here maybe this point also local minimum. Okay, we can write increasing, yes, from negative 3 to negative 2, open from both sides, be careful about this, and also from 0 to positive infinity, decreasing, yes, here from negative 2 to 0, that's it. Also local maximum, negative 2, but what is about y? We can find this from the original function. The original function here, I think, square root x to power 3 plus 3x squared. That's it, yes? This is the equation? Yes, exactly. Okay, now calc negative 2. The answer may be 2. This is local maximum. And also local minimum, okay, at 0. But we can find this is calc 0, also 0. Yes, this is 0. That's it. Thank you for watching video. We'll see you inshallah in the next video.